I need you to stay focused. This is a potential 10 marks question, 6 to 10 marks, okay? And it will come like this. We are doing hardcore application rate. We are fishing. We are solving puzzles. We are solving Sudoku, whatever you call it, right? It's not straightforward at all. Don't worry. Follow me closely, okay? Let's read. In the chemistry experiment, the following observation was noted. Yeah, first line is not a keyword, it's useless. Yeah, sorry to use the word, but yeah, it's useful at all. Next, when a piece of tin is placed in aqueous lead 2 nitrate, it becomes coated with a black deposit. Yeah. So let's take a look at over here. What are the few things I think is important to us? I think, all right, again, color code in my map be accurate, but I'll just do my best, okay? When I add in a piece of tin and I add it into aqueous lead 2 nitrate, correct? These are the keywords. Agree with me? The rest are just rubbish English. Yes? It has nothing to do with science. It becomes coated with a black deposit. Agree? So I have 3 keywords in my first bullet point. Bullet point obviously important. Just like my note, take a look. My notes are in bullet point. Agree? Things important, then we bullet it. If not, bullet for what? The 3 lines to shun it together further what's inside there. Okay. Now, before we carry on, this is a what reaction? Be very clear. Displacement reaction. Okay. So this is a metal displacement reaction. In fact, all of them after you read the second and third one. All of them. So you are very clear. A metal displacement will show us the reactivity, right? Indirectly. So if you appreciate this metal displacement, I would like to first of all write out, hey, what is that black deposit? What is black, my friend? Deposit means it's a solid. It is a solid. Cannot see, write out your metal displacement reaction. Tin plus lead 2 nitrate. They never ask you to write, but because nobody give me the answer, I have to show you. Yes? Thank you. Tin must have push. Again, they never ask you, right? You might ask me, Mr. Chua, how you know tin, right, is like 2 plus? You don't know at the moment until later. So again, you don't have to write this on an exam. Your job is to appreciate that the lead must have been pushed out. See? Because they tell you there is an observation. You suddenly see black. Yes? And I say black means black color in chemistry. I'm not a racist. That's a disclaimer there first. Yes. Cannot. Ready? So everyone okay? Black color. Okay? So I'm very sure I'm going to write it here. This is where we solve it, my friend. So this is black deposit or black solid, okay? So I'm going to write a note here. In an exam, you need to scribble all this out in order to solve it. Yes. Now we are fishing. Later we use the fish to catch bigger fish. Make sense? Okay? Yeah. Okay, then we carry on, okay? Now, when a piece of tin, still tin, right, is placed in aqueous magnesium nitrate. I run out of colors at any of these colors, okay? Oh, there's no change in the appearance is observed. So there is no chemical reaction. And at the same time, I can also conclude this, I hope you agree with me, in black. First line, I know which metal is more reactive. Is it tin or lead? Tin, that's why I displace it, okay? Second one, I also now know that tin is more or less reactive than magnesium. Yes. That's why I cannot push it out. No reaction. You see it? There's nothing discussed or observation. So for the right hand side, nothing at the moment. Yes. Then I carry on to the third one. Oh, so second one, at the moment, there's nothing. Third, when a piece of lead is placed in copper 2 nitrate. I don't know why it's copper 2 nitrate, but I guess it's blue in the short one. Not guess, I see that it's blue. See, it becomes coated with a brownish pink deposit. So the brown color must be due to, or the pink color, brownish pink, must be due to what? Due to a solid that has been displaced. What is a solid has been displaced? See? Correct? That's the displacement. Very easy. So I'm going to start to write here. I'm going to write that copper solid is the brownish pink deposit. As well as they say the color of the solution changes from blue to colorless. Who is blue? They told you one. I didn't memorize. Yes, one more line. Not all copper to something is blue. They could be green. They're in the region of green to blue. You learn this in JC2 last topic called transition metals. Right? Yeah, it's not. Only copper 2 sulfate, once again, is the grandmother of chemistry. The rest, I doubt you need to know. Everyone okay? I just need you to know this. This is blue. The rest, you're just assuming. Good. So again, copper 2 nitrate is a blue solution. I gather from here, right? So we're going to use all these bullet points about. And it becomes what? It becomes colorless. So who is colorless? Who is that colorless thingy? Lead nitrate. Good. So I have one more bullet here. I'm almost there to solve a couple of questions. Right? So also I learned that lead nitrate is colorless. And also I learned that therefore lead is more reactive than copper, which we have memorized it. Okay? The only thing on our syllabus to memorize is technically tin. You ready? Ready, we play. First question, ladies and gentlemen. Predict what changes, if any, there could be no changes at all, will be seen when a piece of tin is placed in aqueous sodium nitrate, the salt solution. Anything? No. Sodium is one of the most reactive metals. So sodium nitrate is very, very stable. All right. So predict what changes? There is no visible observation. Nothing is being observed. Usually we write no visible observation. Second point, you don't need, I'll just write it down. But the whole idea, the reason, right? In case they ask you for reasoning, then you just say sodium, or rather not sodium, the other side. Who do we let? Tin. Tin is definitely less reactive than sodium. And therefore, unable to displace it out from its salt solution. This is a formal statement I will write if they ask me to explain for one more mark. Unable to displace, I mean. Make sense, huh? We are not memorizing anything, we're just playing. And that is what I want you to do. Can I, everyone? Okay, I start to erase off, then we play, huh? So anything that are not necessary, I get it off. It's off, I get this off, right? We'll get 1 mark for that. If they ask me to explain, I'll get 2 marks, okay? Okay, next. Predict what changes, if any, will be seen, part B, if a piece of tin is placed in aqueous copper 2 nitrate. This question, right? So I'll use a space here if you don't mind, part B. You're not sure, I can't think, right? Then just never mind. Just write it out. Ask yourself, write the equation out. Is there anything that will happen over here or scribble somewhere? Correct? Because on top here, we already know their arrangement. Make sense? We already know that what? Magnesium is more reactive than tin. Tin is more reactive than lead. Lead is more reactive than copper. This is what they have told us, 3 bullet points. Okay? Plus this side. Can you see what I'm doing? That's all. Okay? So technically, I can also kind of remove all this, right? I don't need this anymore. I have what I want. Okay, here we go. So I know we're going to form what? I know it's going to form tin nitrate. Again, you don't know that tin is 2 plus at the moment because we're not familiar with tin, but it's okay. At least you scribble somewhere and later you can write the color out, right? So ask yourself, if this reaction occurs as per this equation, what would you see? Number 1, you will see this. You will see a very good copper, which we know, The solid is a brownish pink deposit. Yes, brownish pink deposit is observed. That is a solid that came out, right? What else? Very good, because we know the solution changes from what color? Blue to colorless. We know this is blue, right? Just now we saw already, right? We saw this is blue. Tin nitrate, but tin nitrate, we don't know. Where? First bullet point or first equation, where? Okay, ladies and gentlemen, this is colorless. How do we know it's colorless? Blue solution turns colorless or decolorizes. So, two observations. What I need to discuss now is why is it colorless for that tin nitrate, the one in yellow, right? Why is the color solution? Okay, ready? Now, the first bullet point there, if you observe, follow me closely, is whereby you use aqueous lead 2 nitrate, and there is a displacement we saw, right? That's why you got a black deposit come out. And what did it form? It formed tin nitrate. Agree with me, everyone? Right? You take a look, aqueous lead nitrate, based on the last bullet point, the third bullet point, we know is colorless. Make sense? Correct? It's colorless. And when a solution don't change color at all, therefore, there is no observation to say there is a color change. Are you with me? So people will ignore that the solution remains colorless. Are you with me? It's indirect. Can see now, everyone? Because there's no color change, so no need to discard. Right? Make sense? So if you pick this back up, all right, I can actually include one more here that appreciate that lead, because it's the lead nitrate is after I go to number 3 bullet point, right? I saw it, and that's why now I paddle back to appreciate that, hey, actually first bullet point got indirectly tell me this is also colorless because it's the same color as lead to nitrate. Understand what I'm saying, everyone? It's called paddling back. It's what we do in the application question. Okay? Here we go. Next. Predict what changes done already. Part C, arrange the metals in terms of their decreasing reactivity. I think this is the answer. We already solved it already. All right. Here we go. Where's my pen? This is part C. Okay? This one. Yeah, we have done it. Right, everything is there. Including sodium, sorry. So sodium, we all know where is it. We just have add a sodium on top. Right? Why? Based on our remembering of reactivity series of metal. Am I okay? Anna? Done. Okay, arrange the metals, done already. D, when tin forms a compound, one of the most stable oxidation state. Can you see? Just why I just tell you, I told you, I know tin here is tin 2 plus. Am I okay? The question tell you one. Right. The oxidation state is what? Is very, very similar to your charge of an ion. Remember? That's what I told you. Okay, soon I will go into oxidation state to revise with you again. So when tin forms a compound, it will kind of have +2. So construct an ionic equation to solve the reaction with tin and copper 2 sulfate. So here we go. It's not nitrate, so I cannot use this also. Right? So tin and copper 2 sulfate. So here we go. To do ionic equation and to state the spectator ion, you must first have the balanced chemical equation first. Right? Tin and copper sulfate. So you form tin 2 plus, and therefore this is the salt, and copper is salt. Make sure it's balanced. All right, those that know how to do ionic equation, all right, I taught this in Sec 3. You also should learn it in Sec 3, everyone, right? Is we choose the aqueous one, and then we chop the ion that you see on both sides. And therefore, we know our spectator ion. 1 mark, Spectacular ion is your sulfate ion. They say state. So you can either write the formula or you can say the English word. 2 minus indeed. Yeah. SO4 2 minus sulfate ion. And our equation is nothing but what? But whatever is left behind, just copy it down. So tin is the IE means ionic equation. Tin plus copper 2 plus equals gives you tin 2 plus. And ionic equation, you automatically must put in state symbols. Please take note. They won't ask you. Sometimes they guide you to say which state symbols. Don't have, also must write. Okay? Because that's how we get it. It's through the state symbols. Okay? Easy? Done.
If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.